Hello everyone, this is Yale Shi. I'm going to introduce my final project to you. My final project is a blockchain project which has the name of Yale contract. So this Yale contract is the application for the companies to store their contracts. So contract is widely used in commercial activities, but it really costs a lot of resources, because they may need to pay a lot of money to verify the authenticity, and there's a lot of other things. In this application, the companies can use their private key to sign on the contract and then put them into the blockchain to make them immutable. How does my project works? Suppose company A and company B are going to make a contract. So company A would write this contract and sign it with his own private key and send it to company B. Company B would verify the A contract to see if it is really signed by company A by A's public key, and then sign on the A contract with company B's private key, build a B contract and send it to the miner to let the miner mine. So this is the functionalities. First, generate public key and private key. Second, send public key. Third, key store. The next, sign and verification functions. Next, RESTful API to sign on a contract. And finally, verify and double encryption. So let me show you how the application works. Suppose company A and company B are going to make the contract. Let's say that company A has the address of 6686. Company B has the address of 7000. And I have already rounded up their applications. Let's see that. So we can see in the show, there is only a Genesis block. For both of them. And then let me see, if we call show key, we will say that company B's public key are already in company A's key store. And I think the other side should be the same. Yes, company A's keys is in company B's stores. So this is send public key and the key store. So now A should make a contract. What would she do? She would first open up the plain text. So in the plain text, you should put your contract here. Let's say it is just Hello World blockchain. And company A would call sign. Then it would use his own private key to sign on the contract and make this signature. You can just copy paste it here, but you can also find it here in the sign result. Then A will send the sign result to B's place to let B verify it. And let's say this is happening in B's place. After B received the sign result, he would also put it here. So let's say just judge. Looks like this is the valid signature. Then he should also sign on it. So in the sign result, just copy the signature. Yes, just copy the signature and put into the plain text of his own. Okay. Save it. And then company B would call final. Now he finally signed on the contract. And this is the final contract which would be put into the blockchain. After the final API, company B would put this contract into the contract list and send it to all the miners. So the miners would start to mine it. So if I have to remember, the blockchain should only have the first block, which is the Genesis block. And now we have block 2. So this block 2 means that our contract have already been put into the blockchain. So it means that our project application is working. So let me see what the next thing. I should explain my code. Okay, let's go to my code. So firstly, we should generate public key and private key. When we start the server, this generate will be called to generate key pairs and write the key into the local file. Second, the send public key. So the heartbeat data have another variable which is public key. And when we start heartbeat and send the heartbeat, we would also send the user's own public key to each other. In the key store, we have a key map to store all the others' public keys. So we can also see the RESTful API to see the other one's keys. Okay, next one. So sign and verification. This is pretty simple, just by this function. So RESTful API to sign on contract. I have already showed you the sign, and this is the function of the sign. We first read the plaintext.json and build a struct of signature and sign it and write it to a sign result file and print out. So verify and double encryption. This is very long. I will just go to the original code, which is here. Firstly, we read the sign result and do the stars and read the plaintext, and finally make a signature, and by the signature and the signed, we made the final struct, which is the final contract. It have all these structures, and marshal it to a string, send it to the contract list, and forward the heartbeat so that all the miners knows that this job is in the list. Okay, let me see what the next one. So I should compare what I have planned in the proposal. Okay, actually I have changed a lot of things. So the first one is encryption and decryption factory. The original goal is the factory can encrypt and decrypt the messages, but I think this design is totally wrong. In this project, I should use signing and verifying instead of encryption and decryption, so I changed it. So the next one is contract proposal page. The original goal is provide company B a page to write the content of the contract and send to A after encryption along with the original contract. It is also changed. Instead of providing a form page, I just provide a RESTful API sign to just access the local file and read the plaintext and sign it with its private key. Why I changed this? Because I think this RESTful API would make the user easy to use. And this is the biggest change. So in the original goal, I think I should let company B to mine the AB contract and put it into the blockchain. But I finally, in the end, I found it has a great problem, because it means that only B, okay, whatever A, this means that only B can use the contract to mine. It means that the speed of the contract of being put into the blockchain would be very slow. So I just let the second company to publish that contract, and so that all the miners can mine it. And this is the changed things. So let's see, let's do another things. Let me see if the judge works right. So we have already seen that this a valid signature. It is so this. Let me see. So this sign result is right. So let's see if someone have changed the original plain text, which is, let me say 1, 2, 3, and save it. Let me see, judge should not, let me see. The signature should be changed. Yeah, it is. This is an invalid signature. So I don't know why this is happening. Maybe there might be something not so good. I would just try to fix it. So this is the demo of my project. Thank you for watching.